So the first one, I'm going to go through kind of my calculator process here. With all my numbers typed in, this is the histogram that it gave me. Along with, this was the window that it set by itself. Does this graph look terrible? Not really, not to the point where I'd say run screaming and never try normal. So it doesn't look terrible. Maybe I can make it look better. Which of these things would be what I would try to change? My X scale. So right now it's 2.2. I just went with something easy and went with 2. And it just so happened that when I switched my X scale to 2, I liked the first thing that I tried. There's no rhyme or reason to what you have to pick. Now, if you try to do it and you only have 3 bars, don't pick a number that big. Pick something close to what it picked, but a little bit easier to deal with. So like when you draw it out, just making sure that you guys are okay with this. I did post like a little side video and said, if you don't have a graphing calculator and you need to do this, here are things you could do. And I showed you how in a Google form to find your mean, standard deviation. And I even told you if you need to do stem plot instead, that's fine. I don't care. I didn't have anybody have any come to me with issues. So hopefully that worked out well. So what would I need to write about? Like when I have my histogram, I should physically on my paper also write what? Somewhere here. What did I do here? If you didn't write that somewhere, write that somewhere. And probably with like a circle or star or something to remind yourself, hey, I didn't write that.
So for the width and stuff, do we go up like in increments of 0.5?
So I chose, are you talking about down here?
Yeah.
Because I chose this, and that's why I did a screenshot here. So this one would be 9.4, and it's going up by that. So then this would be 11.4, 13.4.
So, but for the changing to the scale, like I changed mine to 1.8.
So then yours would be 9.4.
So it's just gotta match that. Okay.
Yes, that's your question. Yes, it just matches that.
Thank you.
And the thing is, like, if you do it on a test, yours should be labeled well enough to where if your numbers are completely different and it's a scale that I would have never chosen, it takes me 2 seconds to change my X scale to yours, and then I can check everything about your graph. So it doesn't really matter what you pick there. All right, so that was my step 1. So I made my graph. I checked it off. So that means continue. What's the next thing I need to find out about the information?
Mean and standard deviation.
Mean and standard deviation. So how many decimals did our data values go to? 1. So I want this to 2. So our X bar would be what? And our S would be?
I thought we had to go 3 places.
So if you went to 3, it's fine, but you need to at least go 1 more than the data. So in this one, it was the data was all tenths place, so you need at least go.
Okay.
So if your numbers are different than mine here with rounding, you can still be right, but yours is going to look possibly a little bit different than mine. That's fine. So at this point, I've got 15.59 here. I want to go 3 this way. What are my numbers going to be?
18.4, 20.69,
And then 3 this way, which is my closest one in.
13.04, 10.49, 7.94.
So I also showed you how to sort in Google Sheets if you needed to. But at this point, I would want to sort. So stat, sort A of whatever list it's in. And it says done. Mine's in list 3 here. So if these are in order, I'm looking at this versus these numbers. So how many numbers are below 7.94? And then how much? So some people don't write 0 there, and that's fine. So how many are before I get to 10.491? And then so I can look at this, and so here, before I get to 13.4, that's this number, right? So when I'm when I have it highlighted there, I see down here that I'm at the 6th number. Well, how many numbers were in this group? So if I'm at the 6th number, how many are here? So you can use that to help you too. So then I could go down to where it gets to 15.59. So I'm showing you this. So 15.3 is the first one that is before 15.59. And it is showing me that that is my 20th number. Well, how many were before this? 6. So I can just go. And that helps me a lot more than sitting there and actually like counting through. So like I use that a lot when I'm doing this. You've just got to keep up with the cumulative total. What are my next numbers? 16 what?
7.
Where's yours different? Yours might be different. Questions with anything I've done at this point? And I will tell you that the most common mistake with this is on like a test or quiz is because people overlap this step with this step. And they try to now draw a histogram, but they've already redone the numbers and they get really confused about it on 2 things. So draw your histogram before you ever look up your mean standard deviation, and hopefully that will avoid confusion. So now I have to do my little chart thing here. What's my first column? What do I call my first column?
Within number of standard deviation.
And my options are?
1, 2, 3.
And then which are
68%, 95%, 99.7%.
and the last column is going to be
How are you doing that?
so how many are within 1?
30, which is 68%.
68.18.
Here is going to be what?
42 out of 44.
Which is
95.45.
and then
34 out of 44.
about as close as you can possibly get. So written conclusion here needs to be, and if you didn't write that, you need to. So we can use normal approximation. We did not say our data is normal. We said the word approximation. Since our data follows what? All right, closely to. Is that what I said? Just showing you a little bit more about normal probability plot. This is the normal probability plot for this graph. I know I did not ask you to do anything about this for the homework. Does that look like a dead straight line? No, but do you see the straight line pattern? All right. So if you were trying to sketch this, you can still use trace at this point. So you can't see it here because it's blinking on your calculator, but at this point, you have an x of 9.4 and y of negative 2.277. Here I have this one clicked on, and it tells me the x and y. Here it tells me the x and y. Here it tells me the x and y. So I would need to use these dots to be able to number my X and Y axis correctly, which you would need to do if you graph this. So you would need to use, like, I would need to see where this gap is right here. So it would use the fact that it's just below 17.7, 17.6. So I would see that on the number line. Definitely my lowest Y value is negative 2.2 something. My highest is here. So I would need to see there that this is about 2, which means that's 1. So here's about 2. Oops, my spacing didn't work out there very well there. So I would need to see things like this. What's the label that goes here? These are all what kind of values? Z-scores. These are just whatever the context was. Was it shark what? Shark lengths and feet. I want to show you an example of a normal probability plot that doesn't look like you. Let me just, I'm just plugging in a whole bunch of 1s, some 2s, some 3s, 4, 5, 6, 7, and a 9. So we got a whole bunch of 1s. So I'm going to do a graph. So I just made a graph that looks like this. Does that look anything like approximately normal? So if I were to go make a normal probability plot of it, it looks like this. That looks drastically different than this that slants a little bit. So you're not looking for like a dead straight line. Let me put a piece of paper and make sure it follows a flat pattern. But this is very different than something like this. Now, without these numbers, that would be fine. I just didn't put many numbers in. But that makes it definitely not follow approximately normal. So just kind of showing you deviations from that. Yes. Yes. So continuing on to 65 from that. 65, does that one look approximately where I could use approximately normal or not?
Yes.
So the normal probability plot follows a fairly linear pattern, which means we can use a normal approximation for the data. What about 66? It's not as drastic as the one that I did, but it still has that same thing where it does this and all of a sudden starts to do a line. It's actually the exact same thing here. It's that it's right skewed. There's a whole bunch of dots that have the same value, and then it skews off to the other side. So the main thing I need you to see out of 65, 66 is what looks okay and what doesn't. That Z's go on the y-axis, and if you were to do a fill in the blank, you want the normal probability plot to be blank for the data to be blank. You want the normal probability plot to be fairly linear so the data is approximately normal. All right, number 69. Now, 69 through 74 was a good example of ones that don't show much work, but you should know what work you should put for these. 69 said, which of the following is least likely to have a nearly normal distribution? I don't love this problem, to be honest. Fairly normal, yes or no? Heights of females?
Yes.
Probably. IQ scores of students in that class?
Yeah.
Probably. Math, SAT math scores of students in that math class? Yeah. Family incomes of all students taking that class? That's the one that would be the best choice. Income's got to start somewhere. So it's capped, 0 if nothing else. But it's not capped on the other end. I think some people would look too far into that problem, though, and be like, well, it's at a certain tech school, and then try to think too far into it. But D is your best answer. have this printed up in front of me. Point C, number 70 is what? I'm sure you got the answers. These are pretty quick. C, 78 grams. 71 says about what percent are between 76 and 84? That's the 2 standard deviations, which is B, 95%. About what percent of the cockroaches have weights less than 78 grams?
I said E.
Said what?
I said E.
It should be 16%. It should be C.
How do you get that?
68, 95, 99.7. I'll draw that up. It doesn't even matter what the problem is. I can go straight from tell you that it's this one sitting this way. This percent is what? This percent is what? So that's 16. And I could have done it the other way and added them all up, but that's the easiest way to make sense of it.
Well, I added those two. Because what were those two that are shaded?
You didn't add 0.015 probably. The very last one. Like past 3. Number 73, the portion of observations from a standard normal distribution with values less than. Now, is that really any different than asking what percent fall between? No, it's just, this is basically saying use the yellow sheet instead because it's not on there. So this would be P parentheses Z is less than 1.5. Let me just tell you that I can look at these answers and get close without ever picking out a piece of paper, or at least narrow it down to 3. Proportion of observations from standard deviation, standard normal distribution with values to the left of 1.15, which means how much of the graph am I shading? To the left of Z equals 1.15. More than half. So if there's any answer there that's not more than half, you shouldn't even look at it. What is our Z value? What is our area for a Z value of 1.15?
0.874.
0.8 what?
0.874.
749. It's shaded to the left, so what do I do with it? Leave it. So your answer is C. 74, proportion of observations from a standard normal distribution with values larger than a negative number. So my answer should be what? More than half. What is the value that I get? What is the area when I look up Z equals negative 0.75?
0.2266.
So what do I do with that if I want to shade to the right?
1 minus
1 minus, your answer is
0.7734.
0.7734, which is C. Questions on the homework?